24 from your homework, and I wanted to take time to just talk to you about how you could find your x-intercepts once again on your calculator. So this is the equation from number 24. Could you take a second and type it in your y equals screen for me, please? Oh man. You might just want to jot down like this so you could like have the keystrokes. Okay. You want to make sure as you're looking at this that your stat plot, these three items up here, plot 1, plot 2, plot 3, that those are white. If they're black, you need to shut off those stat plots. I can come around and help you with that. So you type in your equation from number 24, and then you're going to go ahead and press graph. So what's nice about this feature is you could now look at this screen and look at your answer to 24. And in general, I see that my maximum value, my vertex in this case, is hanging out in quadrant 2. So your maximum should be hanging out in quadrant 2. If you recall, your calculator will find that maximum value. So you could press second and calc, and you would choose option 4, as we've kind of done in the past, to verify that maximum value. We'll talk a little bit more about how to verify a maximum in a bit. But for right now, what I wanted to talk about is how we could use this same screen to actually verify my x-intercepts. And what I need to be very clear about is that x-intercepts, there are synonyms for that term. There are a couple different words that different textbooks will use when they say, hey, find x-intercepts. I can think of two right off the top of my head. A synonym for x-intercept might be the term 0. If they say, some books will say, hey, don't find the x-intercepts, but rather find the zeros of the function. And that name kind of makes sense if you give it just a little bit of thought. Remember when we find x-intercepts, you're letting y equal 0, right? So if we're letting y equal 0, we're finding the zeros of the function. Another will just be solutions. Find the solutions. And then lastly, another synonym for x-intercept will be the roots. Some books use roots. So if you see any of that language on different worksheets or in different books, they're just saying, hey, find your x-intercepts. So now let's look at this screen. Which function should I choose? Doug. John. Yes, 0. Woo! All right. Okay, so true story, there's 2 x-intercepts for this parabola, right? I'm going to find one of them, and you're going to click along with me. And then you are independently in your seats going to practice finding the other one. The one on the left is the one we're going to find together. So the one where my cursor is blinking really, really close to right now, that point is the point we're going to find right now. My calculator is going to ask me 3 questions. The first one, left bound. What this is saying is, hey, go to the left of where that x-intercept is. So right now, where my cursor is, it's kind of hard to tell with this particular point, but this cursor is indeed just blinking ever so slightly to the right of this intercept that I need to find. If I move it over here, it's definitely blinking to the right of this intercept I'm trying to find. So it's north and east, so a little bit off to the right of that point I'm trying to find. That's not where I should hit enter, because it's saying find the left bound. So I have to hit the left arrow button a couple times until that cursor is definitely to the left of the point that I'm trying to identify. So do you see now, like if I put my pen here, do you see how my cursor is blinking indeed to the left of that value? So I can now press enter. Then it says, hey, go back to the right. See how it says right bound right here? So now I'm going to take my cursor and make sure it goes to the right of that point I'm trying to find. If you mix up your right from your left, your calculator will not know what to do, and you will get an error message. They'll say like error bound, and that's because it's trying to pull in values that don't have really any overlap. So in this case, do you see how my cursor is blinking to the right of the point I'm trying to find? I can press enter. And then it says, hey, guess. Sure, I'd like you to guess, calculator. And one of your answers when you work out the quadratic formula is negative 3.44. In there somewhere is what you should have gotten. Do you see how on the right, where this y equals is, we have y equals -1e -12? Some of your calculators may have done that, some of them not. Do you know what that number is? Donatus. Oh, you're so good at using context clues. It is up here on my board. 1e to the -12, or 1e -12, I should say, is scientific notation. That's like 1 times 10 to the -12. So quite literally speaking, we have 0.00000000000001. Well, we asked our calculator to guess. It doesn't jump in and use the quadratic formula. It doesn't do that. It uses something called the squeeze theorem. It kind of bounces values off of each other until it can estimate that point where our y value is 0. Right, you are smarter than your calculator like 100% of the time. So it's only making an estimation, and what would we estimate this number to be? 0, very good. So this y value off to the side here, it's just 0. So you don't have to like stress about that. That's just in scientific notation, a number that's really, really close to 0. Okay, so now you get to practice. I want you in your calculator right now, you're going to press second and trace, and then I need you to find that other x-intercept. Okay, I'm going to go ahead and give you a second to do that. I want everybody to leave it on their screen. 4 was that other x-intercept for sure. When you got that x value of 0.44, that is interesting, I think. Do you kind of notice how we had -3.44 and then 0.44? Well, why did that happen? When you get weird decimals like that are the same, that is not a coincidence. Dylan, do you know? Oh, yeah, because parabolas are symmetric. Our x-intercepts are always going to be equidistant from that axis of symmetry. And that's actually an important idea for today's lesson. So what we're going to go ahead and do right now is we're going to segue into today's lesson. You had a little bit of a warm-up that maybe you got a chance to take a look at. With respect to section 4.2 in your notes, graphing quadratic functions in Vertex and then intercept form. While you're digging out your notes, I'll go ahead and let you know that you grabbed 3 pieces of paper total for your homework assignment for tonight. One of them is pink. That is like the key to know all knowledge with regard to parabolas. It's actually our conclusion activity for today. If you don't finish it in class, it is homework. The other paper is 4.2 Practice B, and then the other paper is an answer key to 4.2 Practice B. Let me be very honest with you. 4.2 Practice B, there's a lot of graphing on that. So for the sake of this assignment, let me be very clear. You only have to find what the directions tell you to find. So I just want you to get a little bit of exposure to the other 2 forms. You don't have to go crazy over the quadratic formula or completing the square or anything like that for the sake of this assignment. So for tonight, 4.2 Practice B, you're going to take just a minute to follow the directions. So make sure if it says find the axis of symmetry, you find the axis of symmetry. Okay? If it says find the vertex, you have to find the vertex. So right now you're looking at your warm-up. Joey? That's correct, if we don't finish it in class. Most people are leaving today with like the column and a half done. So they have a column and a half to finish. It looks like 1 and 2, you guys are zipping along through that. So when you're done with 1 and 2, you can go ahead and look up and I'll show you what you should have gotten there. If you want to pass your red folders forward, I can take those out of your way. Whoa. Thanks, Jeff. Notice on number 1, I went ahead and I did the square root method, so I basically sad mapped that first problem. You didn't have to do it that way, though. No, you didn't. All you had to do you could also have just gotten one side equal to 0 and then factored the resulting difference of two perfect squares. So you could have just subtracted 1 from both sides and then did 5x plus 1, 5x minus 1. That's also an option. So your answers there, regardless, you're going to get two answers for that. Positive 1/5 and negative 1/5 would be your answers there. For number 2, again, I did solve that with our SADMEP. When I solve for x, it is often that I feel like I'm like peeling an onion, you know? So I just peel off those layers until I get down to my x value. So I added 2 to both sides. I undid the multiplication of 2/3 by, you could consider this dividing both sides by 2/3 or multiplying by the reciprocal, which is 3/2. It's nice because you end up with a perfect square on the right side. Square root of 9 is plus or minus 3. And then you had to take your x minus 4, set it equal to positive 3. And your x minus 4, set it equal to negative 3. You get 7 and 1. Everybody okay so far? And those V-shaped graphs look really, really good. Bird's eye view. You might recall A, H, and K from your absolute value functions. A, that's the number in front of your absolute value symbol. So in this case, it's negative 1/2. That means the V-shaped graph opens down. It's also a vertical shrink. It's wider than the absolute value of x. I see in my grouping symbols or in my absolute value symbols, I have -2. That means my graph moves to the right 2 spaces. And then I have a k value of -3, which means my graph moves down 3 units. Good looking out. So the vertex is 2, -3, because we moved to the right 2 units and down 3 units. And then my slope on one side was -1/2. My slope on the other side was +1/2. So that makes the size of your V. Remember, it's super important to always label all of your critical points when the directions are super general like that. So here it just says graph, which means I need to think, well, what all do I need for a complete graph? Maxes, mins, intercepts. So my max was just my vertex. That's 2, -3. Luckily, I don't have any x-intercepts on this one, so that saves me a couple steps. But I do have a y-intercept of 0, -4, so I did have to plot that. Okay, so hopefully that bangs the rust off of absolute value functions a little bit for you. Do you remember A, H, and K? Kind of an important thing for today's lessons. Any questions about, like, why is it to the right 2? Why is it down 3? Anything like that? Good. You guys were pretty good at this, so I'm thinking this should go pretty smoothly. All right, so we have 2 forms left for a parabola. One is vertex form, and it's a whole lot like vertex form for your absolute value functions. Do you see how similar? There's even an A, H, and K again. So remember that we have y equals A times the absolute value of x minus h squared plus k. That x minus h, that h value tells you how far your graph is going to move to the right or to the left. And in moving a graph to the right or to the left, we actually get our new axis of symmetry. So the line of symmetry is super easy to find. Just grab your h value. Remember, h is always what's next to a minus sign. So if it's plus, it actually moves to the left, and so your h value would be negative. Little reminder there. Your vertex would then just be h comma k, just like it was in the warm-up. To find your x-intercepts, again, you're going to let y equal 0, and then you're going to have to SADMEP. It's going to look a whole lot like this problem here, number 2, where you had to solve by undoing. It's going to look a lot like that. And then the y-intercept, different from yesterday. Yesterday, you just grabbed that c value, moved on with your day. Well, here, if I want to find the y-intercept, I can't grab the k value, because that's the y value from a vertex. So literally we have to let x equal 0 and then use PEMDAS to evaluate for y. So let's do this. Here, in example 1, we have y equals 2 times the quantity of x minus 2 squared plus 1. Do you see how it fits that vertex form? I could pretty easily see my a of 2. It's a positive number, so I know my parabola is going to smile at me. That means my vertex will ultimately be a minimum. I also notice it's kind of a number bigger than 1, which means this graph is going to be stretched out, if you'll remember how that works. So it's going to be skinnier than x squared. I notice I also have an h value of 2 and a k value of 1. Essentially, this graph would move to the right 2 units and then up 1 unit. So our axis of symmetry, it's just your h value. X will be 2. So you draw it and you label it. My vertex is just h comma k. So if h is 2, this is our h comma k. If h is 2, k is 1. By definition, the vertex must be a point on the axis of symmetry. So when you draw this point, it better be sitting on that dashed line or you messed up. What's up? No, h is 2. Here's why. That's a good question. This is legit. I had to talk about it a couple times today. Remember, h is always what's next to your minus sign. So if it were a plus, yeah. So let's say this were, hypothetically speaking, x plus 2 squared. Remember that that's like x minus a negative 2 squared. So that is the case where you'd be moving the graph to the left. H is tricky because I said it's kind of counterintuitive. The opposite of where you think that should go is where it goes. So it's annoying. H is kind of the one that you have to think a little bit harder about. But yeah, that's the kind of attention to detail that makes a good question. So good question. Any other questions so far? And I'm just following the chart that we just filled in. To find the y-intercept, I'm just going to let x equal 0. So I'm going to find f of 0, basically, my function value at 0. I do that by filling in 0 wherever I see an x. And then I do my order of operations. Two times 4 is 8. 8 plus 1 is 9. So my y-intercept in this case is going to be 0, 9. So you go over 0 and up 1, 2, 3, 4, 5, 6, 7, 8, 9. One of the rows on your pink chart tonight, it says, hey, how do you find some extra points? That question will be the same answer all the way across. Check this out. If you want to find some extra points, remember what we said about the x-intercepts? I think Dylan said it earlier. They're symmetric. So if you want to find the other one, based on the fact that you know what one of them is, just flip it over that axis of symmetry. So check it out. I can do that with my y-intercept too. Do you see how my y-intercept is 2 units away from my axis of symmetry? If I want to get another point for this parabola, I could just flip that 2 units to the right of the axis of symmetry. Okay, Doug, what is your question, sir? Yeah, it makes the parabola frown. It changes the direction, yeah, of the parabola. Yeah. It's not like we can distribute that in, Doug. If we were going to isolate that x value, we'd actually have to divide both sides by that coefficient. So it wouldn't change the sign in between. Good question. So I have some labeling to do, right? So what are your thoughts on x-intercepts for this one? There's none, yeah. It's not like all of a sudden this U-shaped graph is going to change directions on us. I will go ahead and let you know why this happens. So I'm going to give you a little bit of more information there. You know, you would let your y value equal 0. You'd be subtracting 1 from both sides. dividing both sides by 2, kind of like what Doug and I were just talking about there. Uh-oh, look what happens. Ah! You see what happens? Yeah, you have an imaginary solution. X in this case would be I, or plus or minus I root 2 over 2. That's a complex solution. You're not going to graph that on the real number line. So this wouldn't have any x-intercepts. Your domain for this function goes from negative infinity to positive infinity, because they all do, just like yesterday. And then your range, that, however, is limited. I don't get my range values all over the place. Anybody think they know the range of this graph? Ooh, lots of people. Mackenzie. Yeah, it goes from 1 to positive infinity. Nice job. We have one more form. You've actually done this form a little bit. We have our intercept form. And this is just what happens if you factor standard form. You get y equals a times the quantity of x minus p times the quantity of x minus q. P and Q, I'm going to start with intercepts first. P and Q, if you use the zero product property, are your x-intercepts. So you just grab your P, which is also next to a minus sign, and you grab your Q, which is also next to a minus sign, and those are going to be your intercepts. They'll be P comma 0, Q comma 0. We said that x-intercepts earlier in the lesson are always symmetric to an axis of symmetry, which means that the axis of symmetry is exactly halfway between your two x-intercepts. So a real quick and easy formula for your line of symmetry is just to take your P plus your Q and divide it by 2. And then we could use this x value to find your vertex. You plug in your x value from your line of symmetry, and then you just solve for your y value using the order of operations. And then your y-intercept, you also just let x equal 0 and you solve for y. If you ever run into an instance where you want to switch back and forth between the forms you're learning today and the one you did yesterday, you could just FOIL. And that's what example 2 is about. So example 2, if you want to switch 3 times x plus 2 times x minus 5 to be in standard form, you could just FOIL and then distribute that 3 in. What's up, Joey? Zero product property. We set each of your parentheses that have an x in them equal to 0. I think the more pressing piece of information that I probably need to start you on would be that next example. Does anybody have any questions about FOIL? I think you guys, based on stuff I've seen before, are pretty good with FOIL. Any questions about how to turn one form into another? Because you do have that on your assignment tonight. Yep. Okay. Last problem of the day. So what I notice is that in example 3, we have a is -2, a p value of 1, and a q value of 5. So if I want to find my axis of symmetry, I just do p plus q over 2. Well, that's supposed to be a q. So I'm going to do 1 plus 5 over 2. That is 6 over 2, which is 3. Yeah. So p and q are, again, like h, attached to minus signs. So if it said plus, Joey, that's the case, again, where you'd have to switch it. Does that make sense? Okay. So like similar to what we were just talking about. So yeah, that's a great question. So we're going to go over 3, draw our dashed line. And then the rest of the problem, honestly, is just kind of like what we just did. If you want to find your vertex, you would take your 3, and you could just plug it in. watch your order of operations. So you got to do your grouping symbols first. And then this would be 8. So we get the point 3, comma 8. We know our x-intercepts already, so I'm going to jump down and do that. That's just your P and your Q. So there's not really a whole lot of work for these. It's just 1, 0 and 5, 0. Y-intercept, we're just going to let x equal 0 and do your order of operations. Whew. That is it. So you get 0, -10. This guy down here. You're just kind of drawing your U-shaped graph and label it. So again, when it says graph on your homework tonight, you're not doing all of it start to finish. You're just doing the pieces that it says. That's like death by parabolas. Just follow the directions. So if it says just find the axis of symmetry, just find the axis of symmetry. Yeah. Yeah. So on that problem, for instance, you wouldn't have to go through all the work to find the x-intercepts. You could just estimate where they are. Does that make sense? Okay.